Clouds bring glorious panhandle sunsets or strong thunderstorms. At West Texas A&M University, researchers are looking into how aerosols, which are tiny particles not visible to the naked eye, affect how clouds form. Aerosols include dust and other matter suspended in the air. They can be natural or man-made, solid or liquid, and as small as 1/10 the width of a human hair.
And we believe those aerosols are interacting with moistures in the cloud or in the atmosphere. So aerosols interacts with cloud, and that aerosol cloud interactions have something to do with the climate. And that has to be having something to do with Arctic climate change.
In his lab, Hiranuma and his graduate students are working on an international project sponsored by the Japanese government to study that interaction. The study focuses on ice formation, or a scientific process called nucleation. Here is usually what happens. Water vapor rises, freezes, and condenses into clouds. Regular water droplets freeze at certain temperatures, but aerosols behave differently. The water they collect can freeze at much warmer temperatures. Using a specially built trapping device, Hiranuma collects air samples. His work has taken him from a remote island deep in the Arctic Ocean to working along with cattle producers in the feedlots of Northwest Texas.
Each facilities, if they have a size of 1 square miles, they have more likely, more than 15,000 cattle, and they emit a lot of particles towards the end of the day. When the temperature is getting cooler and cattle gets more active, and they start generating, the dust. And also here in West Texas, we have coal combustion, facilities just northeast of Amarillo. And they emit a lot of ash in the atmosphere, and ash is known as containing a lot of mineral dust.
Hiranuma looks at how different shapes and types of aerosols affect freezing levels.
Seeing that some of them becoming droplets.
The findings could shed light on a common Texas Panhandle problem: hail.
I am actually hoping to find the way of predicting and potentially preventing hail formation in the future.
His research has global significance. Aerosols are so tiny that their impacts often are left out of climate predictions, and by adding his findings, Hiranuma will help better forecast the Earth's future.
Missing or ignoring identities of individual particles, that's generating a lot of uncertainties or the errors in our climate projection. Me as atmospheric scientist, I'm trying to fill the gap, right? And I'm trying to constrain more of measurements and try to minimize the uncertainties so that we can predict our climate in the future. That's what we're looking at specifically in this facility at West Texas A&M University.